Okay, 6.3, now that we know how to find intercepts from 6.2, we actually have to graph using intercepts. And we also know how to do this from chapter 5. If you're given intercept form, we know how to graph, but we don't know how to get to intercept form. However, now we do. We've learned in chapter 5 to come up with intercept form from standard form through a process called factoring. We know how to find the vertex when we have two intercepts because it's the midpoint. So if we have two intercepts and the vertex, that's all we really need in order to graph, a crappy little graph that I'm going to do on this whiteboard. So let's get started. First of all, to find the x-intercept, I'm going to set this equal to 0, and I'm going to factor this with a 1 and a 7. Again, if I'm factoring too quick for you, you take your time when you factor. It doesn't have to be at my pace. I know that if I find the intercepts, it's going to be a -1 and a -7. So my graph, I kind of already know how it's going to look like, right? It's going to be like this. At -1 and at -7, I should have drawn this differently. I need more negatives in the x. At -1 and at -7, I have a parabola that opens up. So I kind of already know that it looks like this. I just don't know where this vertex is because the question says, find the vertex after the intercepts. Questions aren't going to say this. If it says graph, you have to know to find the intercepts and then the vertex. You have to know that. Those are the three things you need. Can you do it with just the vertex? Yeah, kind of. Can you do it with just the x-intercepts? Not really, because without the vertex, it's going to be hard to graph a parabola. So, where is the vertex? We know where it is. It is on the axis of symmetry, right between the -7 and the -1. So the x value of the vertex is -7 plus -1 over 2. The x value of the vertex is -4. So this is x equals -4. So right now I would know the vertex. The x value is -4, and I just don't know the y value. So what do? I plug it back in to either here or here. I can say y equals -4 plus 1, -4 plus 7. Which one would you choose? I probably always choose factor form. I rather multiply two numbers instead of squaring things, adding a multiple of. When there's negatives, it's annoying, so I'd rather use this form. -4 plus 1 is a -3. -4 plus 7 is +3. So this is -9. I now know the vertex. The vertex is -4 and -9. So I know the two intercepts. Boom. I found the vertex now by finding the midpoint of the intercept, plugging it back in, finding the y value. There it is. There's nothing else I need to graph this parabola. Done. Okay. Now let's take a look at this one. Yeah, we have to factor again. No problem. 1 and a 6 and a 2 and a 3. I got to subtract to get a -1. 4 and 3, there it is. So I'm going to set this equal to 0. Remember, I'm doing this on my own, right? Because it's saying find the x-intercept. Because it's saying find the x-intercept, I'm setting this equal to 0. Open up brackets, x, 2x, 2 with the 2 on the inside, 1 with the 3 on the outside. Signs are different. Bigger one's negative. 4 is bigger, so it takes the negative. So now I know that x equals 2 and x equals opposite this over this. Remember from 6.2, that video. Okay, so I found my intercept. Do I need to graph it yet? No, I don't need to graph it yet. I can just do all the math first. Sometimes I like having a graph going on the side because if I have to graph the graph anyways, I'd rather have a visual representation while I'm doing my math. It's no extra work, but it's going to help me visualize what's happening. So because I don't have the space here, I'm not going to do that. I got to find the midpoint between 2 and the -3 over 2. If you want to change that to a -1.5, I don't recommend it, but you can. Of course you can. So the x value of the vertex is 2 plus -1.5 over 2. 2 plus -1.5 is 0.5 over 2 is 0.25 or 1 over 4. Now I have to plug this back into my equation. So y equals 0.25 minus 2. I'm going to use 1 over 4. Because I would have used fractions. I would have never gotten this to 0.25. I would have added these as fractions and then divided them by 2, and I would have got 1 over 4. Okay. 1 over 4 minus 2 is the first bracket. 2 times 1 over 4 plus 3 is the second bracket. I'm running out of space. I don't know why I put this many questions up here, but it's okay. This is a 1 minus 8 over 4 remember my fraction method, just multiply that up there. 1 minus 8 over 4. 1 minus 8 is negative 7 over 4. This is 1 over 2. I'm going to do the 2 over 4. So I'm imagining here a 1 over 2 plus 3, right? I'm not going to do that extra step, but I'm going to say, well, now it's 1 plus 6 over 2. 1 plus 6 over 2 is 7 over 2. And now I know the y value is going to be negative 49 over 8 of my vertex. I'm just going to graph it here and avoid one of these questions. So to graph this now, I know I have these two. I'm going to label the 2. I'm going to label the negative 3 over 2. The vertex is x is 0.25 here somewhere. And at negative 49 over 8. If you don't know what that is, change it to a decimal. It's like down here somewhere. Label it, negative 49 over 8. Draw your parabola. Don't forget your arrows. And you're done. Beautiful. You found the two x-intercepts. You did a bunch of math. Honestly, guys, this is calculator work. Just plug this into your calculator, plug this into your calculator, get your answer, and graph your vertex. It's not a big deal. I do want to talk about this guy, though. I'm going to cancel out this guy. Who cares? We'll do it another time. When you have a negative a value, factor it out. Don't rock with an a value that's negative when you are factoring. So the first thing I'm going to do is factor out the a value. I do this for my whole life. I would never want to deal with the negative value in front of there. Take it out. All the signs change. And now I notice that because this is positive, this could be a perfect square trinomial. Does the root of this, 3, times this, the root of this, x, doubled equals this? Yes. So y equals negative x minus 3 squared. Now, if you don't know how I got there, you need to work on chapter 5. You need to know how to factor perfect square trinomials. If you want to do it the long way, go ahead, but you have to get to this point in whatever method you choose. Now, you might be confused. Wait a minute. How can there only be one intercept here? Well, this is going to look at 3, right? I know x equals 3 is the only intercept. We can call it a double 0, a double intercept at 3. This parabola opens down, so I know that it's going to open like this. But sir, I need to find other points. Sure, you want to find some other points? Plug in 0 into x and find out where it hits the y-axis. That's another good point. You can plug in a 2, but I don't want to plug in a 2. I'd rather plug in a 0, because if I can find this point, I can mirror it on this side, and I'll have pretty good parabola there. So if I plug in 0 over here, I'm going to get negative 3 squared is positive 9, so negative 9. So I know this hits at negative 9 somewhere down here, wherever it is. Negative 9. And I know this is also going to be negative 9. So I can anchor those points with this guy. Done. Okay. So yes, I could have only one 0. I could have 2 zeros. There's some times where I could have no zeros because the parabola opens down and the x-axis is out of reach. So there's 3 different scenarios. I could have 2 zeros, I can have 1 0, or I can have no zeros. Okay, and that's pretty much all 6.3 because we already know how to do this. There's just some busy work that we got to deal with that we actually did in chapter 4. You learned how to find the vertex already. Okay, there might be just other scenarios that we need to know how to factor before we can kind of figure out the rest.
Pretty easy.